Welcome back to this tutorial on TensorFlow, a powerful open source library for machine learning and deep learning developed by Google. TensorFlow is widely used in both academia and industry due to its flexibility and efficiency in handling complex computations and building neural networks. In this video, we'll walk you through the process of building a simple neural network using TensorFlow and Keras, its high-level API. We'll cover everything from setting up your environment to loading and pre-processing data, building the model, training it, and making predictions. Whether you're a beginner or someone looking to solidify your understanding of deep learning, this tutorial is designed to be accessible and informative. By the end of this video, we will have a functional model that can predict outcomes based on input data, and you'll be equipped with the knowledge to expand on its foundation for your own projects. Let's get started. Before we dive into coding, we need to ensure that TensorFlow is installed in our environment. If you're using Google Colab, TensorFlow is pre-installed. However, if you're working locally, you can install it using a pip command. Pip install TensorFlow will install the TensorFlow library, so we can leverage its capabilities for building and training our own neural networks. Now let's import the dependencies. We'll be using TensorFlow, Keras, and a few utility libraries like scikit-learn for data processing. This code will import everything you will need. Now let's load our dataset. For this example, we'll use a hypothetical chart where we want to predict customer churn based on various features. We read the dataset using pandas and separate the features from the target variable. The train test split function divides our data into training and testing sets, with 20% reserved for testing. After that, we'll use standard scaler to standardize the values, ensuring they have a mean of 0 and a standard deviation of 1. This normalization process helps in speeding up convergence during training. Now let's actually build our model. With our data prepared, we can now build our neural network model. We'll create a sequential model, which allows us to stack layers sequentially. The first layer has 32 neurons and uses the ReLU activation function, which introduces non-linearity into the model. The second layer has 64 neurons and also uses ReLU. The output layer has a single neuron with a sigmoid function, making it suitable for binary classification tasks, as it outputs a probability between 1 and 0. Next, we need to compile the model. This step configures the learning process. We're using the Atom optimizer, which is a popular choice due to its efficiency in adjusting the learning rate during training. The loss function is binary cross-entropy, suitable for our binary classification problem, and will track accuracy as a performance metric during training. Now it's time to train our model using the training data. We fit the model on our training data for 50 epochs, which means the model will see the entire dataset 50 times. A batch size of 10 means the model will update its weights after processing 10 samples at a time. We also set aside 20% of our training data for validation, allowing us to monitor how well our model performs on unseen data during training. After training, we can use our model to make predictions on our new data. The predict method generates predictions on our taste datasets. We then convert these predictions into binary classes by applying a threshold of 0.5. This means if the predictability probability is greater than 0.5, we classify it as a 1, otherwise a 0.
Thanks for watching. If this video was helpful, please like and subscribe to our channel for more tips and tutorials.